Hello students, welcome to EPG Pathshala. I am Vikas Singla from Punjabi University, Patiala. Today we are going to talk on module Trend and Seasonal Methods of Forecasting from paper Operations Management. After completing this module, you should be able to understand following three aspects. Firstly, trend method of variation in data and its quantitative forecasting method. Secondly, seasonal method of data variation. And lastly, multiplicative method of data prediction if it is varying in a seasonal manner. Previous module discussed time series methods of forecasting when data variation occurred over a short-term period. Also, the fluctuation behavior of data was random and unknown. This module would focus on methods of forecasting when variation data is occurring from short to mid-term period. Quarterly sales, sales of products depending on weather conditions, traffic congestion on daily basis, movie ticket sales during weekends are some of the examples that fall in the category of such time period. Moreover, such data show a particular behavior in its variation. Sale of smartphones shows an increasing trend, whereas sales of desktop shows a decreasing trend over a monthly or quarterly time period. Whereas sale of milk products, demand of winter clothing, demand of electricity, rush hours shows cyclical trend occurring over regular time period. In all such cases, data does follow a particular pattern which was missing in random variations. Thus, this module focuses on two forecasting techniques, namely trend and seasonal, used when data variation shows either of the following pattern over a specified time interval. Firstly, either increasing or decreasing, which are discussed under category of trend method, and secondly, regularly repeating upward or downward movements at regular intervals, which has been discussed under seasonal method. Selection of these models is based mainly on following two considerations. Firstly, time horizon to forecast, which can be short term, medium term, or long term. Secondly, pattern of demand variation, which was categorized into four types, that is, demand can vary randomly, trend-wise, seasonally, or cyclically. This chapter discusses models when time horizon to forecast is short to medium term. For example, quarterly sales, sales of products depending on weather conditions, traffic congestion on daily basis, movie ticket sales during weekends are some of the examples that fall in the category of such time period. During such time period, demand variation shows either trend pattern or seasonal pattern. Trend pattern of variation means that data variation shows either increasing or decreasing trend over a specific time interval. For instance, sale of smartphones shows an increasing trend, whereas sales of desktops is showing a decreasing trend over a quarterly time period. Thus, in this example, data variation of smartphones is increasing, where that of desktops is decreasing. Also, this variation occurs over a medium term of a quarter. Seasonal pattern of variation means that data variation shows regularly repeating upward or downward movements at regular intervals. For example, sale of milk products, demand of winter clothing, demand of electricity, rush hours show cyclical trend occurring over a regular time period. In the same example, demand of electricity increases during summer months and drops during winter months. This happens over a specific time interval. Also, this happens repeatedly in that time interval. Graphical representation of trend and seasonal demand pattern has been illustrated in the following graph. It is important to understand that the x-axis of this graph shows monthly time period and y-axis shows sales data. The graph shows two line curves. The red line indicates an increasing trend of sales over monthly time period. This is an example of trend pattern. Green line shows sales varying in increasing and decreasing cyclical pattern over the same time period of month. This is an example of seasonal pattern. The following slide explains the trend method of forecasting. Trend method involves relationship between two variables. Firstly, independent variable, which is designated as X, is the controlled variable which a manager can change, such as time of production, money spent on advertisement, etc. Other variable, that is dependent variable, which is designated as Y, is the variable that needs to be estimated or forecasted, such as sales, etc. Thus, the objective is to find the effect of independent on dependent variable and use it for forecasting the dependent variable. The quantitative method of forecasting a demand, which shows a trend variation, is called as simple linear regression model. The linear regression analysis is used for forecasting, assuming that firstly, the relationship between x and y is linear. Second, x, that is the independent variable, causes y, which is the dependent variable, and x or independent variable is the time period. Such a basic regression model is represented as dependent or predicted variable, that is y, is equal to intercept, that is a, plus slope, that is b, into independent or predictor variable, that is x. The formula is represented in the equation form, which is y is equal to a plus bx. Simple linear regression formulas for calculating a and b is shown in this slide. A, which is the intercept in the equation, is given as average of y minus b into average of x. But a can only be estimated or calculated after calculating b. B is the slope of the regression line. B can be calculated by using the formula, which is summation of multiplication of x and y subtracted from n into multiplication of averages of x and y, which is divided by sum of x square and minus of n into average of x square. The estimation of demand, which varies according to a trend, is illustrated by using the following example. This example also indicates the two applications of the trend method. The application 1 of the trend method is that it can be used to predict future demand. Secondly, the trend method can also be used to forecast demand for each period, which can be calculated and compared with actual demand to find forecast errors. These two applications have been illustrated in the following example. The following data, as shown in the table, will be used to illustrate both the applications of the trend method. The following data indicates a firm's sales for a product line during 13 quarters of past 3 years. We need to forecast sales for each quarter of fourth year. For instance, the table indicates that the quarter 1 sales is 600 units, quarter 2 sales is 1550 units, and so on and so forth. It is important to mention here that the quarter or the time period is the independent variable x, whereas sales is the dependent variable as y. By using these two data and the above discussed formulas for the intercept A and the slope of regression line B, the regression line y is equal to a plus bx is estimated. The first step is to have a multiplication of x and y, which is given in the third column of the table. For instance, for the first quarter, that is 1, and the sales 600, the multiplication of 1 and 600 will give us 600. For second quarter, that is time period 2, and sales 1550, the multiplication will give us 3100. Lastly, the fourth column gives us the values of square of the independent variable. Square of first time period, that is 1, is 1. Square of second time period 2 is 4, and so on and so forth. Sum of each column is given in the last row. By using the formula for slope intercept B as given in the equation discussed above, it was estimated that B would be 358.91. Similarly, A is calculated by using formula given in the equation, and A would be A is equal to 462.87. Thus, the regression equation becomes y is equal to 462.87 plus 358.91 into x. For all quarters of fourth year, that is for period 13, 14, 15 and 16, sales were forecasted by using the above estimated equation. Forecast for period 13 would be 468.87 plus 358.91 into 13, which would be 5138.7. Similarly, for other time periods, that is 14, 15 and 16, forecast has been calculated by putting these values in the equation. For instance, forecast for period 14 would be 462.87 plus 358.91 into 14. Forecast for next time period has been calculated in the same fashion. The purpose of slide is to illustrate the application 2, which is the comparison of actual sales and forecasted sales. The comparison has been illustrated or explained in a graphical form. This graph indicates two lines. The blue line indicates the actual demand, whereas the red line indicates the forecasted demand. As can be seen from the graph, the forecasted demand is showing an increasing trend and has smoothened the data, thus implying that the forecasted demand can be estimated more accurately by using the trend method. This slide indicates another illustration of trend method by using simple linear regression method. The example shows that a manufacturing company produces a spare part in batches which vary in size as demand fluctuates. The table contains data on batch size and number of man-hours required to produce a particular batch. It was suggested that larger batch size would require more effort in terms of time taken to produce. Also, estimate mean number of hours required to produce a batch of 55 units. For instance, the table indicates that batch size of 30 units takes 73 hours. Batch size of 20 units take 50 man hours. Now the question is, how many man hours are required to produce a batch of 55 units? The most important thing to understand in this example is that the time period is taken as the dependent variable and batch size is the independent variable. So a causal effect has to be understood before forecasting the demand by using simple linear regression. Indicates the solution for this method, which is as amount of time taken to produce a particular batch depends on size of that batch. So batch size is considered as independent variable and man hours as dependent variable. By using equation 2, which was discussed in the application 1 of trend method, and using the values of the above table, we can calculate values of A and B. The value of B by using the explained formula comes out to be 2, whereas value of A comes out to be 10. By putting these values in the regression equation, the equation becomes y is equal to 10 plus 2x. And estimated man hours for batch size of 55 can be predicted by using this equation. In the above equation, x would be replaced by 55, which is the independent variable. So estimated man hours for 55 unit batch size would be 10 plus 2 into 55, and the answer would be 130 man hours. Now we will discuss seasonal method of forecasting. Seasonal variations in time series data represent upward or downward movement occurring repeatedly at regular intervals. For instance, sales of winter clothes increases during winter months and decreases during summer months. Same cycle gets repeated after same time period. Two essential characteristics of seasonal variations is that first, every cycle of upward and downward movement repeats itself after similar time period. And secondly, regular cycles can be used to infer the time for which there would be an increase and time for which there would be a decrease in demand. For example, rush hours happen twice a day. For illustration purposes, suppose there is increase in traffic during 2 hours in the morning and for 2 hours in evening every day. So in this cycle, there would be increase during morning and then traffic would start decreasing, which would again increase during evening and then again would drop. This cycle repeats itself every day regularly, making it a seasonal variation where each season is of one day. So if naive forecast is used, then demand for Tuesday can be estimated as demand for Monday during peak hours. Similarly, in case of a barber shop, there is increase in demand of haircuts during Sundays and then drops. This cycle gets repeated every week. In this case, each season is of 1 week. Demand of haircuts for one Saturday can be estimated as demand for previous Saturday. Models of seasonality. To estimate seasonal forecast, there are two different models, additive and multiplicative. In the additive model, seasonality is expressed as a quantity which is added or subtracted to average of the data. In the multiplicative model, seasonality is expressed as percentage of the average amount, which is then used to multiply the value of series to incorporate seasonality. These seasonal percentages are termed as seasonal indexes. For instance, seasonal index of 1.20 regarding sales of toys for a particular time period suggests that sales of toys for that quarter are 20% more than the average sales. Similarly, seasonal index of 0.90 would imply that sales for that period are 10% below the average. This chapter discusses only multiplicative model as this model is more widely used and it tends to be more representative of actual forecast. The data as shown in the table clearly depicts seasonal pattern of a particular business. It was tentatively estimated by looking at increasing trend of demand per year that total demand in fifth year would be 2600 units. We need to predict quarterly demand for fifth year. The data indicates demand for each quarter for 4 years. For instance, demand for first quarter of the first year is 45 units. For second quarter of the same year is 335 units. the total demand for year 1 is 1000 units. Similarly, first quarter demand for year 4 is 100 units. For quarter 2 for year 4 is 725 units, and total demand in year 4 is 2200 units. Some important points that should be considered by looking at the data. Firstly, the data shows that there is increase in demand as we move from first quarter, which peaks in third quarter and then shows a decline in fourth quarter. This cycle gets repeated for every year in 4-year data shown. Second, here data of each year is divided into 4 seasons pertaining to quarterly data. If we use naive forecast, then demand for next season, that is first quarter of 5th year, would be more than 100. So quarter-wise demand comparison follows a trend pattern, whereas year-wise comparison indicates seasonal pattern with increase and decrease components. Step 1. Firstly, calculate average demand per season. For year 1, average demand per season would be total demand divided by number of quarters, that is 1000 units divided by 4, which would be 250 units. For year 2, total actual demand is 1300 units and there are 4 quarters, so average demand per season for year 2 would be 1300 divided by 4 equal to 300 units. Similarly, for year 3, it would be 1800 divided by 4, which would be 450 units. Lastly, for year 4, it would be 2200 divided by 4, that is 550 units. Step 2 in the method of seasonal forecasting would be calculation of seasonal indices, which is done by dividing the actual demand for a season by the average demand of that season. It has been shown in the following table. For quarter 1 in year 1, it would be 45 divided by 250. For the same year, the seasonal index for quarter 2 would be the actual demand, which is 335, divided by average demand of that season, which is 250. For year 1 and third quarter, the actual demand is 520 units and average demand for that season is 250. So the seasonal index for that quarter would be 520 divided by 250. Lastly, for year 1 and quarter 4, the actual demand is 200 units and average demand for that season is 250, giving us a seasonal index of 100 divided by 250. This is being done for each time period for each quarter. Step 3 is to calculate the average of seasonal indices of each season, which is done as for first quarter for each year. The seasonal index has been calculated in step 2. In this step, the average of these seasonal indices is calculated. For instance, for quarter 1, the average of seasonal index would be 0.18 plus 0.23 plus 0.22 plus 0.18 divided by 4, which would be 0.20. The average of seasonal index for quarter 2 for the 4-year data would be 1.30. Average of seasonal index of quarter 3 is 2.00. Lastly, average of seasonal index of fourth quarter is 0.50. Step 4. As it has been estimated that 5th year demand would be 2600 units, so it can be suggested that average demand per quarter in 5th year would be 2600 divided by 4 is equal to 650 units. Thus, quarterly forecast can be made by multiplying the seasonal index of each quarter with average demand of that quarter. That is, forecast demand of first quarter of 5th year is equal to 650 into 0.20, which is 130 units. Forecast demand of second quarter of 5th year is 650 into 1.30, which is 845 units. Similarly, for forecast demand of third quarter of fifth year is 650 into 2.00, which is 1300 units. Lastly, forecast demand of fourth quarter of fifth year is 650 into 0.50, which is 325 units. To conclude, this chapter discusses forecasting techniques when data shows a certain pattern over short to medium term. Specifically, trend and seasonal methods have been discussed with some illustrations. Trend method pertains to either increasing or decreasing fluctuation of data over selected time period. Such time period can be daily, weekly or monthly, but preferably should be less than 1 year. Trend method involves time series data and uses method of linear regression for prediction purposes. Causal method also uses same methodology but does not involve time series data. Seasonal method of forecasting is used where data shows both increasing and decreasing pattern over a certain time period. In this method, pattern is repeated over regular interval of time period. Multiplicative method of prediction has been illustrated as it is more representative of forecast. Thank you.